Okay guys, welcome back to another epic Inexorable video. In this video we're taking a look at the final thing from quadratic equations. We're looking at modelling with quadratic equations, okay? What is that? What does that mean? Just a little thing, just a little heads up guys. You have, if you've watched all the previous videos on quadratics, you've learned all of it. You've learned all the quadratic stuff, which is absolutely exquisite. So this is all applying knowledge into real life things. Now this is not necessarily easy, you know. Some of these questions can be hard because they like to give you funny numbers in these modelling questions instead of easy numbers like whole numbers. They give you funny numbers, they give you stuff in the wrong order, they might want you to complete the square, they might want you to use the quadratic formula, the discriminant, all sorts of things. They will ask you everything from quadratics in these, okay? So, what is a model? Why do we model in maths? Why do we use quadratic equations to model? Well, do you remember, if you saw it, the first video that I did on quadratics? The first video that I did on quadratics, it was called Introduction to Quadratics. I spoke a little bit about how we use quadratics to model real life situations. Now, nicely for us, quadratics do something brilliant. Quadratic equations can sort of show the path of any projectile that has been thrown that is subject to gravity that is not under the influence of things like air resistance, rotational forces. If you imagine like a little point mass, like a tiny little infinitesimally small mass, and it can feel gravity and air resistance can't do anything to it, and you threw it up exactly horizontally, even downwards, as long as it's not like straight downwards, even sort of at an angle downwards, the path that its trajectory makes will be a parabola. And a parabola is the shape of any quadratic equation. Any. If you plot it on a graph, any quadratic equation with A, B, and C coefficients that are real, so real numbers, any of them, you will have, beautifully, a parabola. And that is the shape that anything falling makes. So if I throw something across the room, it will come up, and it will come down, and that will be a quadratic equation. You can also use it for things that aren't projectiles, but this question is about a projectile. So without further ado, let's just sort of get into it. Let's analyze it. You'll get lots of questions asking you, what is this? What does this number represent? You'll get that in all of A-level maths, but they love to do it in these because this is an easier topic relatively in the grand scheme of the whole A-level. Obviously, it's near the beginning. It makes sense. You guys will come to be really good, but this is one of the easier topics considered to be. So they like to ask you hard questions on it. You'll get this in your real exam for sure, or there's a high chance of it. So here's the question. If you can't read my handwriting, which is not very good, I'm going to stand over here just so you can read it. A spear is thrown over level ground from the top of a tower. The height in meters from the spear above ground after t seconds is modelled by the function h of t equals 12.25 plus 14.7t minus 4.9 t squared, where t must be greater than or equal to 0, okay? Why should t be greater than or equal to 0, guys? Because if t was negative, remember, t stands for time, t seconds. T is a measure of time, okay? If t was negative, that would not make any sense. We'd be going backwards through time. And unless you're like Doctor Who or something, you're probably not going to be going backwards through time. Or maybe the third album by Ailstorm, Back Through Time. I really, really don't think that we're going to be doing that. We're going to be going forwards through time, or we're going to be at the initial moment, which is when t is 0. So because of this little line on the inequality, t can be 0, but it cannot be anything less than 0, okay? The question is, after how many seconds does the spear hit the ground, okay? How many seconds does it take for the spear to hit the ground? Right, first of all, guys, I'm going to ask you a question. Right, one thing is notice they've written this in the wrong order, because that's actually A, that's B, and that's C. But it's written, as you might assume, A, B, C. Well, the t squared means this must be A, minus 4.9 must be A. That's B because it's got a t in front of it, and that's C because it's a constant. So we're saying t is kind of like the x in this. And h, or h of t, is kind of like y, okay? My question to you, being vigilant of the order that all of these things are in, is what does 12.25 represent? Okay, so I'm going to sort of have that as an open question, and I'm going to draw it, and I want you to think about it whilst I'm explaining what's going on, okay? What is this number? What does it represent? Okay, have a think. Okay, so we're going to draw it. I'm going to draw it with you guys. This is the t-axis. We're going to call this the h-axis, okay? So here's our sphere. Now, c is always the y-intercept. The y-intercept here is 12.25, so I'm going to say that's the y-intercept. And now I'm just going to use a calculator because you are allowed a calculator in every A-level exam that you sit. At least for Edexcel, that's the case. I can't speak for other exam boards, but for Edexcel, definitely, you will not enter an A-level maths exam without a calculator, unless you woke up without your head on and you, for some reason, forgot to bring one, or something awful has happened, okay? So let's just calculate what this graph looks like. Oh, just dropped my pen lid. I've done that a couple of times, guys. Bit clumsy. Okay, let's just plot this graph. Sometimes it's really easy to plot it, just do it quickly, okay? That's why I don't use a ruler. I don't want to spend ages doing it when we have vital exam time right here. So let's plot some things. I'm using a calculator. I'm just using the quadratic formula to do this, because why not? Save yourself a calculator. I'm getting that one of the t-intercepts, that's basically an x-intercept, right? You'll get loads of questions with t instead of an x, it's just the same thing. I've got a point that looks like it's about there, and I'll tell you what that is in a second. And I've got a point that looks like it's about there, okay? I'm going to link them all up. It's a sad face. I know it's a sad face because A, which deceivingly is on the wrong side, but that is A because it's got the t squared in front of it. A is negative. It's negative, it's a sad face, okay? So I know it's a sad face. I know that that's there. I know that these are here. Now these points are, this one here is 3 minus root 19 over 2. That's the t part. And the h part is 0. So it's got coordinates 3 minus root 19 over 2, 0. And this one here is 3 plus, I think, 3 plus root 19 over 2, 0, okay? And this point here, as we know, I know it's getting a bit complicated, is 12.25. It's really small there, but that says 0, 12.25. Okay, so now guys, there's actually something that's helping us a lot here. T is greater than or equal to 0. What does that mean? It means I'm about to get a rag out and rub something off the board. What am I about to rub off the board, guys? I'm going to rub off everything that is left of the h-axis. Why? Because everything to the left of the h-axis is when t is a negative number, and it is not defined when t is a negative number. So this is gone. Gone, 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 gone with the wind. Literally just disappeared, okay? Just like the sphere, it is kind of gone with the wind. So that's 0 seconds there. We actually just don't care about anything happening on the left of the h-axis because we don't care when t is negative. Everything over here, t is negative, and it clearly says it can't be. So this is the shape that our sphere has made. It makes total sense, doesn't it? Because if I was to throw a spear like this and go like that, yes, it would go through the air, come up a little bit, and then come back down, which is exactly what's happened here, although I haven't seemed to have drawn it perfectly, but it's sort of going like this. It's making like an arced shape. It's making a parabola, okay? So the question is, 2 questions. Or the first one here, this is the actual main question. This is like what you'll actually get marks on. After how many seconds does the spear hit the ground? All right, we'll get to that in a second. You might see it already. You might be a step ahead of me. My question though is, what is this 12.25? What is it? I'll tell you. Think about it, guys. At t equals 0, that goes to 0, that goes to 0, and that would mean that when t is 0, I'm going to write this in, when t is 0, h is equal to 12.25 plus 0, because t is 0, so it's 0 times 14.7, minus 0, because it's 4.9 times 0 squared, which is 0. So the only thing that gets left over is the 12.25, which means that at the initial time, the little, like literally, like the spear has not even left the guy's hand, right? Or girl's hand, you know, whatever. The moment before it's even left the hand, the initial height that the spear was thrown from must be this. The initial height. Before it's even been thrown, the C value must be the initial height. So the answer is 12.25 represents the height that the spear was actually thrown from. You might say, well, hold on, 12.25 meters, you know, who are we talking about, right? Gulliver's Travels? Well, there's loads of reasons. They could be standing on top of a platform. It could have actually been launched by something that isn't a human. It could have been launched by a machine that's on a platform. It could have been anything, it could be all sorts of things. The spear has been launched from 12.25 meters into the air. The person could be standing on top of a cliff, on a hill, literally anything. So many reasons, okay? That actually could be a 1-mark exam question in and of itself, by the way. Interpret the value of the 12.25. So the answer there would be, that's the height that it's thrown from, okay? So the real question is, after how many seconds does the spear hit the ground? Okay, how many seconds? Guys, I've got a question to you. When something hits the ground, how many meters off the ground is it? It's 0 meters off the ground, right? If something hits the ground, it's on the ground. There is 0 meters on the ground. So the way that we find the amount of time that something takes to touch the ground is we set the height equal to 0, because we want to find t when the height is 0. So let's just do it. 0 equals 12.25 plus 14.7t minus 4.9t squared. But hold on, guys. Because we're well-prepared individuals, we actually have already worked this out, because we've sketched it. When is the height 0? Positive, 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 0, negative, negative, negative. It's 0 on this line, on the t line, right? On the t-axis. That is when h is 0. H is 0 across the entire thing, which means that it's 0 when t is 3 plus root 19 over 2. And guys, I'm not a god, okay, and I don't know what 3 plus root 19 over 2 is. So I'm just going to use a calculator, because you're allowed a calculator in an exam. So 3 plus root 19 over 2 is approximately, oh, that's not a very good thing. So a sort of wavy equal sign means roughly equal to, approximately equal to, so I'm going to use that because it's not exact. And I'm going to get it as a decimal, and that's going to be 3.67945, roughly, okay? So, and that's going to be in seconds as well. I'm going to write seconds, you can write S, but my S's kind of look like 5s. As you can clearly see, that's a 5, that's an S. They look really similar. Okay, so guys, we need to investigate this. It will sometimes tell you in the exam, give your answer to some number of significant figures, decimal places, whatever. Let's say it says to 3 significant figures. All we want is to put this into 3 significant figures, and that's going to be roughly 3.68 seconds. And then in brackets, I'm going to write 3SF, which stands for significant figures. Now, it might say 2 significant figures. It might say 2 decimal places. Whatever it says, just do it, and you get this. So the answer would be that. If you plug 3.68 into this formula for t, you should get 0 or very close to 0, because we have rounded it. It was not going to be exact, but you should get more or less a 0, which means it's touched the ground at that moment. Okay guys, last part of this question, it's a bit of a doozy. We want to find the maximum height of the spear and what time that height is reached, okay? I've left the graph on the board because I think it could help us, but okay guys. So from the graphing video, I hope that you guys saw that. How do you find maximum and minimum points? Vertexes, maxima, minima, Anything come to mind? Completing the square is the answer to that question that I just asked you. So guys, complete the square formula, forget it, don't worry about it, we don't actually need it. We're going to complete the square on h of t, okay? And everything will be revealed, don't worry. We're just going to complete the square, this is good practice for us, okay? So I would say maybe we should use the formula. Maybe we should actually, because this looks like a bit of a nightmarish question for completing the square. So let's just do it, guys. So I'm going to put the formula over here. So y equals, oh, actually let's use h's, guys. Let's use h's because we're in the h world. We're in the h realm. Is going to be a times t, because we're using t's, plus b over 2a squared plus c minus b squared over 4a, okay? That is the completing the square formula, okay? Very cool. And I've put a t there instead of an x and a h instead of a y, okay? So h of t, h, doesn't matter what it's called. We're going to just write this in. I'm actually going to put this a little bit to the left. And we're looking at h equals a minus 4.9. And then we're going to open a bracket, and that's going to say t plus, and obviously we're going to use a calculator, guys, because we're not buffoons and we don't want to risk messing things up. So it's going to be 14.7, because 14.7 is b. And we're dividing by two lots of a. A is minus 4.9. So 2 times minus 4.9. I've got, oh that's nice, I've just got minus 3 over 2. So t minus 3 over 2 squared. And then we're going to plus c, so 12.25. And then we're going to minus b squared. B squared is 14.7 squared. And we're going to divide that by 4a, which is going to be 4 times minus 4.9. And we get plus 931 over 40. I personally like to write my decimals as, or my numbers as fractions instead of decimals, because I just think it's nicer, it's neater, and you're giving it in the exact form, which is nice. You're not going to make any errors. Except here, I've put a decimal there, because why not? Okay, mix up a little bit. Right, h is this, okay, guys? So, we want the maximum height, okay? The maximum height. Now, this whole thing, this bit, has got a negative sign in front of it because it's minus 4.9. So if this bracket here that's being squared becomes large, the whole thing will decrease, and we don't want that to happen. We don't want it to get smaller. We want to find the maximum point, which looks like it's going to be, I mean, perhaps I haven't drawn it totally accurately. Maybe it looks more like that. It looks like it's sort of going to be about there. Maybe that's the maximum height, this point here. So we're looking for this t value, we'll call it capital T, and we're sort of looking for this h value there, we'll call it capital H, I guess. Doesn't really matter. So we're looking for, I haven't drawn it very neatly, my writing's awful, but we're looking for this point. We want this whole thing to be as small as possible, 0 in fact, because otherwise, if this gets bigger, h gets smaller. We don't want it. The reason why if this gets bigger, h gets smaller, is because this gets big, becomes positive because it's being squared, and then it times by a negative number, so it will always be negative. We don't want that. So we want to minimize this. We want to make it 0. So how do we make this bracket 0, guys? Something minus 3 over 2 is 0. 3 over 2. So we're going to say that t is 3 over 2. I hope that that was a logical step. We're going to put 3 over 2 where t is. That bracket goes to 0. 0 squared is 0. All of this is 0. If all of this is 0, we get h is equal to 0 plus 931 over 40. So h is 931 over 40. And it's that simple. So we've just completed the square on it. And all we're doing is our coordinates for the maximum height are just going to be 3 over 2, 931 over 40. Which means if you have to actually sort of answer it, find the maximum height of the sphere, you don't want to give it as a coordinate, you want to actually sort of give it as what it is. And what it is, as normally you want a decimal, I'm going to use a calculator. That's obviously 1.5. So the time that it takes, or the amount of time after it's been launched that it actually sort of reaches its maximum height, is it reaches its maximum height at 1.5 seconds in. So it's 1.5 seconds. All right, I've really emphasized that S. And 931 over 40, I'm just going to check that. As a decimal, that's about 23.275. So capital T is 1.5 and capital H is 23.275. In other words, the maximum height of this sphere, no, I said it right the first time. So you're saying sphere in maths, that when you say spear, you think you said it wrong. The maximum height of this sphere is 23.275. That's the highest altitude that it reaches above the ground. And it reaches that height 1.5 seconds after it has been thrown. If this ending bit with completing the square is confusing in any way, I do have a video about this. This is the graphing quadratics part 2 video, and I think I go into a little bit more detail about why all of this happens. Again, if you're not feeling this, if you're feeling like I still don't understand, please write a comment. I will make another video explaining in more depth. And that goes for any video. Just please guys let me know what you think about these videos. I really hope that I'm communicating properly. It's quite difficult sometimes because these are weird, wacky concepts. We don't have long to make these videos. So thank you guys so much for watching. I highly appreciate it. Like, subscribe, share, tell your friends about how you modeled with quadratics this morning, evening, afternoon, night, whatever you want to call it. Tell your friends all about it, and I'll see you guys in the next one. Cheers.